Thank you very much for that, David, for that insightful presentation. Our next presenter is Zhen, Lead Application Engineer at SLM Solutions in Singapore. He will speak about the key considerations for successful AM adoption, conventional versus additive manufacturing, and some examples of AM adoption in ASEAN.
Hello everyone. Today I'm proud to sharing our topics, roadmap to successful AM adoption. So I'm Zhen from SLM Solutions. First of all, please allow me to quickly introduce myself. So I'm Zhen, the lead application engineer from SLM Solutions Singapore. 7 years ago, I started my journey in AM, and since 4 years ago, I specialized myself in metal AM. So for today, I will be sharing on the global successful AM adoption at the beginning. Afterwards, I will share the growth of AM market and industrialization. More importantly, I will share the 4 key considerations for successful AM adoption. And lastly, I will share the AM adoption cases in Southeast Asia. Eventually, I will draw my conclusion remarks. So to kickstart, I would like to present one of the global AM adoption cases from Bugatti, which is a 3D printed titanium brake caliper. So this is one of the latest Bugatti race car, Chiron. And within this race car, there is one of the largest functional component, fully 3D printed in titanium alloy. On the right, you can see this is the topology optimized titanium brake caliper. So it achieved a very high tensile strength of more than 1.2 kN per millimeter square, and it is also 2 kg lighter than its originally 4.9 kilograms machine aluminum counterpart. So it was produced on our SLM 500 core laser system, and it also successfully passed the functional test. Therefore, it is in every customer's final aim to achieve such AM adoption cases. And for today, later I will be sharing more details and factors how we can achieve such successful AM adoption cases. So to give an overview first, this is a current overview of the stage of AM adoption and market growth. So as you can see from the left to right, there are many industries, and some of them are in the early stage, while some of them already about to enter the mature stage. So for today, we try to specialize in these few industry sectors, which are more popular in Southeast Asia, such as oil and gas, industrial goods like molding and tooling, aerospace, and medical. So in terms of the transitioning to industrialization, on the left, this is show a progress diagram. So around 10 to 20 years ago, in phase 1, many customers, they focus on R&D and prototyping first. And in the current phase, which is the recent 3 to 5 years, some customers, they are entering the transition and the transformation stage, where they started small series production as phase 2. And lastly, everyone or every customer, they are aiming for the high adoption and the scaling, which is the mass production in the end, which is phase 3. So if you look at the right, there are quite a few sectors. So for you as AM adopters, you can actually focus on the first column, where you can show how you can adopt AM step by step. So at the start for phase 1, you can work on proof of concept and building your internal knowledge. Afterwards, when you move on to phase 2, you can do part selection and qualification or certifications. And this is also the time for you to build up your first business cases. And eventually, once you enter phase 3, this will be the time for you to fully integrate AM production chain and design for AM. Therefore, for today, in order to adopt AM, I would like to share 4 key considerations for you. So these factors are design, materials, process, and economics. So firstly, let me talk about design. Design will be important for you to achieve a really high quality part. So let me start with a case study from BMW. So this is a convertible bracket used in one of the BMW sports car. So on the right, you can see how design changes in many iterations. From the most left, that's the original plastic injection molding ones, to all the way to the right, which is designed for AM. So eventually, the quality-wise, this bracket becomes 10 times stiffer and 44% lighter with adopting AM. And this is also under serial production which is produced on qualified SLM machines around the clock. Hence, in order to adopt AM in terms of design, you can always ask yourself, does my design maximize the product performance through many factors like shapes, size, structures, and the material compositions? Also, you can ask yourself, does my design consider the limitations and the capabilities of AM? And lastly, does my design take advantages of the unique ability of AM? Some of the questions may be hard if you are new to AM, and that's why for us, for SLM Solutions, we are here to support all our customers, especially at the starting stage, where we can support heavily on the design and optimizations. So this is how we can help in terms of the design for all the customers. So the next will be materials. Material is also critical for a successful AM adoption because material builds the foundation of your parts. So there are many properties from the materials which will affect your final part quality, such as surface, strength, accuracy, stress, density, and hardness. So conventionally, the parts built from SLM can always be considered as a casting replacement, which means if right now you want to adopt AM, you can first consider whether you have any past casting part, and you can try using metal AM to replace them at the start. So that's why for material properties, such as all the above mentioned points, they can be as a reference point for you to choose the right materials from AM. And in AM, there will be one guidelines, which means garbage in, garbage out. That means the quality of your materials will really affect your final quality significantly. That's why it's pretty important for you to ensure that you are using the good materials. And that's why how SLM Solutions can help you will be, we do have a wide range of qualified material solutions for our customers. So when you are new to AM, you can actually work with us and we can assure you the mechanical properties with all of these 6 big categories of metal materials. Next, the process. AM process is critical in getting a final good quality part. So this is one overview of the whole AM production chain. And that's why for you to adopt AM, you need to be really visionary, forward-looking, and equipped with a systems engineering method, which means you need to really take care and cover all of the scope here. And among all the process, these 2 are the most important factors for you to consider: scalability and repeatability. You can ask yourself, what is the state of the art for AM now? Can we do it, or can't we do it? Secondly, how do we scale up AM as a viable production and distribution strategy? How fast we can do it? How can we guarantee the repeatability of quality for AM parts? How well we can achieve by adopting AM? So these are the fundamental questions you can ask yourself before adopting AM. And in summary, this becomes one sentence, and which means how to achieve the maximum productivity and ensure consistent optimum quality of every single part, every single time across different machines and multiple sites across the world. This will be for all the customers who are about to enter phase 3 to answer. Therefore, for SLM Solutions, we try to help our customers in process by providing our state-of-the-art machines. So I won't go into details for today, but these are a quick overview of some of the existing models from us for you to print small parts to big parts. So for SLM Solutions, we believe in multi-laser technology to boost your productivity at no compensation of your part quality. So every time when people talking about multi-laser working together, they always have doubts over the overlap region where 2 lasers are working together. So for us, we run numerous tests, and from the right, you can actually see those blue bars are part quality printed from single laser, and those gray bars are the part quality printed from multiple lasers, which 2 lasers printed the same part together. And as you can see, across different materials, different parameters, there is no big change in the part quality. However, with the adoption of multi-lasers with different parameters, so for example, for now, you can see ranging from 30 microns to all the way 90 microns and up to 700 watt laser. it actually boosts the productivity by 200%. And as you can see in the middle, these are the densities. All are more than 99.9%, and the part quality also did not vary at all. And therefore, for us, we aim to offer the best quality result with also very high productivity for all our customers. And lastly, when we talk about the factors, cost is also critical. So this is an overview of some of the parts of the cost. So on the left, you can actually see this is the cost comparing with the conventional manufacturing with laser beam melting, which is the AM process. So if you're looking at the lot size, which means when you are printing small amount of products, the cost of AM, this dotted line, will be much lower than your conventional method. And if you move to the right, this x-axis becomes the product complexity, which means when you are produce parts in very high complexity, the cost of AM will also be lower than your conventional manufacturing. Therefore, if you want to start to adopt AM for your first cases, we would recommend you can start something in small amount but with high complexity. And this can help you to achieve the cost effectiveness for adopting AM. So to show you a quick example, this is actually a complicated motor bracket in aluminum alloy. So as you can see, with our SLM productivity ranging from 280 single laser to twin laser system, and finally to the quad laser system of SM500, you can see the part build time reduced from 8 hours plus to 6 hours, and eventually it reached only 3 hours plus per part. And the cost also decreased from nearly 500 euro to 375 euros in the end. And this shows how multi-laser and how productivity can help you to save the cost as well. Therefore, in summary, you need to build up your first successful business cases, and then that's when you can achieve snowball effect by stating more values, benefits, and justify your decisions to all your managers and your peers in the team. Therefore, to give a brief summary, these are the 4 key factors you can consider: design, materials, process, and economics. So now we are about to enter the last chapter for today's sharing, where I will be sharing some of the AM adoption cases in Southeast Asia's region. So due to many NDA signed with our customers, I cannot review every single case. So for all the cases I shared later, they are either available online or we have the agreement with our customers to publicize all the cases. So first of all, on the right, you can see a very big part. This is the anti-cavitation tree used in the valving industry. So this is from our customer, Emerson, who has 5 SLM500 quality systems from us. So for this big part, it's printed in 316L stainless steel in 40 micron parameters. And it's very big, as you can see, it's around 280 millimeters in diameter, which can never be fabricated by conventional method in the past due to all of the complicated geometries and the size. But however, with adopting AM, this will be the actual successful AM adoption cases from Emerson, from a lot of other examples. Next, I will show you the next case, which is from Omni Mold. And this product is a core insert for plastic injection mold, where they actually develop the hybrid conformal cooling inserts. So on the right, you can see conventionally, this is how the core insert will look like. They will machine out the whole part, and then they will machine and drill through the internal cooling channels in the middle. However, with empowerment from our SLM280 twin laser system, what they do in the hybrid way will be, so at the beginning, they will still machine out these pink areas with relatively simple geometries. Afterwards, they only use SLM or AM to fabricate this yellow part on top, which has a complex conformal cooling channel inside. So this will be the actual part, how they load this machine part into the machine first, following by they using SLM to print it the upper complicated conformal cooling part onto this machine part. And eventually this is the final product. So you may ask, what's the benefits of adopting AM? So as you can see, with adopting AM, the printing time is reduced from 5 days to within 20 hours. And for this product performance, the cycle time is reduced from 45 seconds to 25 seconds with better part quality. Therefore, it is concluded that with adopting AM, it allows OMIMO to achieve design freedom at a lower cost. Next, I will be sharing another NAMIC project, which is actually a collaboration between different parties. So first of all, we have shippass.com, who has strong network with a lot of marine customers. And the ABS, American Bureau of Shipping, they are the certification body to certify metal parts. And also Nanyang Polytechnics, so they are the manufacturer with our SLM 280 twin laser system machines. And in the end, for SLM, we are the technical consultant for our customers in the region. So eventually, parties working together, and we want to certify the metal AM part for marine applications. And this is so for you, if you are new to AM adoption, you can always try to work with partners and friends in the field to accelerate your process instead of tanking everything on your own. Next, this is a collaboration project between SLM and NTU, Nanyang Technological University. So in this case, we actually fabricate one whole assembly of an electrical motor mount base and the facial clutch for a race car. So as you can see on the right, we already loaded in the electrical motor, and we are testing the full assembly, which are purely metal printed in titanium alloy. So as you can see, it is fully functional in working under the actual motor test. And right now we are waiting for the race car team to put this whole assembly onto the actual car to run the road test. So it's a 250 millimeters gear assembly with AM. We actually save 38% of the weight and reduce the number of components for the whole assembly from 16 to 10. So as you can see from the side, all of these parts are optimized to save the weight while ensuring the strength. So the last case I want to share will be, this will be another battery hull for a submarine robots from NUS, National University of Singapore. So working together with SLM, we also printed this whole battery hull in aluminum parts, and it also achieved a weight reduction of 55%, and we also reduced the volume of the part by 47%. And it also passed the underwater test and will be used on one of the latest NUS submarine robots. With this, we do have a lot of other collaboration cases globally. Due to time constraint, I will go through them in details one by one. So here I would like to draw my conclusion remark for today. So first of all, I want to share the bigger pictures of the step-by-step of phases when you adopt AM, ranging from R&D all the way to the mass production in the end. And the next, there will be 4 key factors for you to consider when you adopt AM. So they are design, materials, process, and economics. And lastly, I also share a lot of local AM adoption cases for you to study as a reference. So as a conclusion remark, as I mentioned earlier, for AM adoption, productivity and quality are always the key concern. And that's why last week, for us, SLM Solutions, we also review our latest machine, next generation machine, with 12 1,000 watt lasers, building parts on 600 and 600 millimeters base plate size. So as you can see on the bottom right, 12 lasers are working together to form a big part for actual applications. And this can achieve 20 times faster than SLM 280 single laser machines. And this is what we believe for those customers who enter phase 3, this will be the powerful tool to really adopt AM at large scale. So with this, thank you very much for your attention. I do look forward for your Q&A in the later sessions. Thank you very much.